Okay, so starting with number 8 on the worksheet, look at the information that the problem gives you, okay? Now, I want you to look at, so it gives you an X, an 8, and a 4, right? Well, which triangle are X and 8 associated with? Big, medium, or small? Okay, so in the medium triangle, what are the terms for those? We could call that long leg and short leg. X is the long leg, 8 is the short leg. You follow that? So if we have long over short, then what triangle has 4 as the short leg? Big, medium, or small? Okay, the small. So if it has 4 as the short leg, then what's the long leg of that one? Yep. So that's what goes where the question mark is. Does that help make sense of it? And then you can solve that, okay? Cross multiply, divide. So you'll do the same thing for 10. So for 10, you start out with 5 over x. So where does that 5 come from? Yes, 5 comes from adding the 4 and the 1. So that's the largest triangle, right? What is the term for that side of the triangle? Hypotenuse. Okay, good. So we have 5 over x. What is x on the big triangle? Okay, so we have hypotenuse over long side, or the long leg, equals, so now x is the hypotenuse of which other triangle? Small, medium? Okay, so it's the hypotenuse of the medium. So now we need to have the long leg of the medium triangle on the bottom. So do you see what goes on the bottom there? Yep, 4 will go on the bottom because that's the long leg of that triangle. And then you cross multiply and divide there. Now remember, x times x is x squared, not 2x, okay? Does that help clear those up for you too, Natalie Campbell? Campbell, is that good for you too? Okay, good. So let's see, 16 and 17. Oh, hold on. 4.5 for number 10, Campbell? Yes. Okay, Charlotte Ann, I didn't work number 9. You can leave it in simplest radical form for that one because it doesn't say to give a decimal on that, Natalie. So it's the square root of 20, and then that reduces down. 20 breaks out into 4 times 5. Yeah, 2 square root 5. All right, Charlotte Ann. So I didn't do number 9. So let's look at that real quick, and then we'll move on to 16 and 17. So for number 9, you have 12 over x. So okay, my image is not showing up well. This number here is actually 12. So if this side here is 12 over x, Charlotte Ann, is that your small, medium, or big triangle? Okay, so on that one, you're using the medium triangle, and 12 is that the long side, short side? And then it's over x. So is x the short side or the hypotenuse? Okay, x is not the hypotenuse. The hypotenuse is the side that's across from the right angle. So if we're looking at just this medium triangle here, right, then that's the short side. Does that make sense? Okay. So for that, you've got long over short, right? So x, let me erase them so we can see. So x in the other triangle as a long side, is that the long side of the big triangle or the small triangle? Yeah, it's the long side of the small triangle. So then we're going to need the short side of the small triangle to go on the bottom. So do you see what number will go on the bottom then? Yeah, 3. And then you'll cross multiply and divide there. Does that help make more sense of it? Okay, good. So now, let's see, girls. We said 16 and 17 also. Do you still need help on those, or did explaining 8, 9, and 10 help you? Okay. So if we look at 16, let me see. Let me see if I can zoom in a little bit. Okay. So looking at 16, we're supposed to tell whether the triangle is a right triangle. If so, find the length of the altitude to the hypotenuse, and then round decimal answers to the 10th. So first off, is it a right triangle? Okay, yes, Campbell, you're right. It is a right triangle because 12 squared plus 6 squared equals 6 square roots of 5 squared. Okay. So the next thing to do is find the length of the hypotenuse to the altitude. So what that means is we're going to have to draw that altitude in because it's not there. So that would be the altitude, okay? Something like that. then we're going to have to figure out what information we have so we can set up proportions, okay? So we need to find, we'll call this H, all right? We need to find H. That's what it's asking us. So what that is, that's the long leg of the small triangle, right? It could also be the short leg of the medium triangle. You see it? Okay. So you could set up your proportion two different ways. I don't want people to see how I do it and think that the way they did it is wrong, even though they came up with the right answer. Because you could do it using the information from the small or the middle triangle. And we have all of the sides for the large triangle. Okay. So I'm going to use the small triangle. So that will be, let's do long over hypotenuse. Okay. So the long side of that triangle, of the small triangle, is H, and the hypotenuse is 6. So then what would be the other side? We need a long of the big triangle over the hypotenuse. No, Campbell, that's backwards. We need, you said 6 square root 5 over 12. We need 12 to be on top because we're doing long over hypotenuse, okay? So we'll do the long side of the big triangle is 12 over the hypotenuse, which is 6 square root 5. Okay, so then you're going to cross multiply and divide by that one. And Natalie, that's correct for number 15. All right, we need number 17 still. No, Natalie, it's not 6. Okay, so let's look at 17. It's not 1. For 17, you're designing a doorstop that you want to be 2 inches tall. Other information is given in the diagram, so that means there's more numbers over there. How long is the base length B in inches? So if we look at that, B we can see is what measurement for the big triangle? Yeah, it's the hypotenuse. So we have that hypotenuse. That's what we're going to have to solve for, right? Is B. But do we have any other measurements from the big triangle? No, we don't. Let's see, do you have your notes pages? Look at theorem 7.6. So do you see how this triangle looks very similar to the one in theorem 7.6? So if we apply that theorem to this, we don't know this length here, but we can assign a variable to that and solve for it and then add 1 to it to get b, right? So remember, what we have to do to apply that theorem is we have to set up our proportion, and we're going to have the hypotenuse be on the bottom on one side and the top on the other, okay? Or sorry, not the hypotenuse, the altitude. So on the bottom over here would be 2, and then on the top over here would be 2, because that's our altitude, right? Now, it's proportional with the lengths of the two segments that it cuts the hypotenuse into. So in that case, oh, let's see, Campbell number 4. Yeah, like number 4. So since it cuts this hypotenuse into these two parts, right? We'll put 1 there, and then we can make that x. So then when you cross multiply and divide, find out what x is, then you just add 1 to that. Yep, Campbell, that's right. Yes, Natalie, you're right. No. B is not 4. Yeah. Does that make more sense of all that? Always look at it and see, like, give a label like long side, short side, hypotenuse, and set your proportion up like that. Long side over hypotenuse, and then long side over hypotenuse of a different triangle. No, Natalie. So when you do 6 times 12, what do you get? So Natalie, 5.3 is close, but you got to round to the nearest tenth. Yep, that's it. We can do bookwork. Isn't that just all of the questions, Campbell? Oh, you're good on 19 and 20? So Charlotte Ann, before we get to the bookwork, Natalie and Campbell, let me help Charlotte Ann before we move on, okay? Remember, Charlotte Ann, that we have, when you divide these triangles into these different parts here by dropping an altitude down from the hypotenuse, or sorry, from the right angle down to the hypotenuse, that we divided into 3 similar triangles. So if we, let me erase some of this, okay. So if we look at number 8, okay, we've got 1 triangle, 2 triangles, 3 triangles, right? So if this top one is our big triangle, we don't know either of the legs, right? Because looking at our big triangle, here's the long leg and the short leg. We don't know that. But we do know the hypotenuse is broken up into x plus 4, right? Then if we look at our medium triangle, okay, so we look at it next. We've got the long leg, which is x, and then we've got that short leg, which is 8. Okay, and now let's change over and look at our small triangle. Our small triangle, we have the long leg, which is 8, and the short leg, which is 4. Okay, so if we look at the proportion, how they have it set up, the first one they give us is x over 8. Okay, so which triangle does x and 8 come from? Comes from the medium triangle. And x is your long side on the medium triangle, right? And then 8 is your short side. So the way they set that up was long over short, right? So then if you look at the other proportion, this one here, or ratio, if we look at that other side, we have something over 4. So what we know is that 4 has to be the short side of one of the triangles. So which triangle is 4 the short side of? Okay, so then do we know the long side of the small triangle? So that's what would go on top, because remember the long side goes on top. So that's going to be 8 over 4. Does that help make it more clear? Okay, so I would color code your triangles if you need to, or down underneath like this on your work, list out your, draw out your pictures of your triangles and label them like I did over here on the side. Just do that underneath each picture. If that's what you need to do to be able to keep it straight, because like I said, I have a very hard time just looking at this picture without marking it up and being able to tell anything from it. I almost have to draw out like this over here. So you okay if we move on to bookwork? Okay. So let's see. You guys wanted to start with number 5. So let me pull that up. Yes, Natalie. So looking at number 5, this is going to be the same type of thing. We have to look at it and see, okay, we have measurements for, really these two triangles look very similar, okay? And they have the same hypotenuse measurement. So we have the hypotenuse of one, the hypotenuse of the other, and then of the big triangle, we have leg, leg, and hypotenuse, okay? So basically that tells us we're going to have to set that up as leg over hypotenuse, right? And now it doesn't matter. You could do hypotenuse over leg. You're still going to come out with the same answer because ultimately you're still going to be cross multiplying and dividing by the same numbers. So leg over hypotenuse of the big triangle would be 76. Oh, that did not turn out very pretty. Over 107.5. And then remember, we know the hypotenuse of these other triangles, right? So it would be over 76. And then you'd cross multiply 76 by 76 and divide by 107.5. Okay? So for 6 and 7, you're going to do that same thing. You're going to figure out if you've got hypotenuse leg, hypotenuse short leg, long leg, what measurement you have, set up your proportion from one triangle, and then set up your proportion for the other triangle. But keep in mind, like on number 6, you're solving for that altitude, okay? Now, the altitude is either the short side of your medium triangle or it's the long side of your small triangle. So when you set up your proportion, you need to either be using a short side or a long side of another triangle. Does that make sense? Okay. So that's how you'll do 6 and 7 as well. No, Natalie, it's not. Hey, Megan. So I goofed when I put number 32 on your homework. It should be 30 and 31, okay? I just realized it when I started Math Lab. So go back and do number 30. And you guys hold on just a second and I'll make an announcement on the classroom about it too so that no one else is confused. Okay, there. So let's see, Natalie, 26.6 the length of the hypotenuse or the medium one? So 26.6 on number 6 is the length of the hypotenuse of the large triangle. Okay, it's that whole side. And then 5.8 is the length of the whole side for number 7, that whole hypotenuse. Yes, Campbell, that's right. Yep, you're right, Campbell. Okay, Devin, hold on. I'm pulling up 13, 14, 15 right now, okay? So for 13, 14, and 15, you're supposed to find the value of the variable and then round the decimal to the nearest tenth, okay? So for 13, you got to look at that and see what information you're given, okay? You have information from your big triangle, right? You have a side and then the hypotenuse. And then from this small triangle, you also have a hypotenuse and a side. So you're going to use that information to set up your proportion that way. Does that help? Ish. Okay. So we have, for number 13, we have a leg. Let me turn my pen back on. We have a leg and a hypotenuse, right? For the big triangle. You see that part? Okay. Yeah, Lily, I'll get to yours in just a minute, okay? So we have leg and hypotenuse for the big triangle. Do we have a leg and the hypotenuse for a different triangle too? So you're going to set your proportion up leg over hypotenuse equals leg over hypotenuse, okay? So then for 14, if we look at 14, what do we have? Well, looking at the little triangle, we see we have the short side and the long side, right? And then if we look at this medium triangle, we have the short side and the long side as well. So we could set up our proportion short over long, right? For 13, you've got to do your answer in decimal form, Campbell. So then if we look at 15 again, you've got your short side and your hypotenuse, right? Of the little triangle. And then 27 would be our short side and Z would be our hypotenuse of the big triangle, sorry. So you can set that up as short over hypotenuse. Yes, Natalie. Yes, Campbell. Okay, let's see. What did we all need? Number 30 next. Natalie. All right, hold on. Let me pull that up. So Charlotte Ann, for finding the altitude, look at theorem 7.6 in your notes. Okay, that's going to show you how to set that up. Let's see, 30 and 31. So if we look at 30, let me zoom in. You want to determine the height of a monument at a local park. Use cardboard square to line up the top and bottom of the monument. Mary measures the vertical distance from the ground to your eye and the distance. They need to find some more fun things to do. Measures the distance from your ground to your eye and the distance from you to the monument. Approximate the height of the monument as shown at the left below. So for number 30, we're only focusing on the left side of the picture. Okay, this looks very similar to me to one of the questions in your notes that we talked about yesterday. And it's not sharing the screen at all. Yes, Campbell. Okay, so do you guys see which problem in your notes that this is like? Yeah, it's like example 4. So if we look at that picture, okay, what are we trying to solve? What measurement are we looking for? Good one, Natalie. Yes, we are looking for X, which is the height of the monument. Okay, so we're looking for this whole thing here. So is that a hypotenuse? So this side is a hypotenuse, right? And we have an altitude that's drawn from the right angle to the hypotenuse, and it divides it into two sections. So when we set that up, we're going to have a proportion like this, right? And we know that that altitude divides the hypotenuse into two sections. And if we set it up like example 4 or like theorem 7.6 shows, which of those two numbers is your altitude? Yes, so that's right, Devin, 7.2. So we're going to have 7.2 here and 7.2 here. Now, what are we going to put on the other two parts? Here and here. Okay, X and 5.5. Now, it doesn't matter which one you put where, it's going to be the same thing. So you're going to have 7.2 squared equals 5.5x. Okay. So what do we get for x? Yeah, so x is 9.4. Is that the answer? Right, that is not the answer. So what else do we need to do? Add 5.5. So 9.4 plus 5.5 will give you the answer because that's the whole height of the monument, okay? Yes, girls. I think it's funny you all got 3 different answers. Okay, so for 31, Paul is standing on the other side of the monument. So we're looking at the right-hand side now. He has a piece of rope staked at the base of the monument. He extends the rope to the cardboard square he's holding that's lined up to the top and bottom of the monument. Use the information in the diagram to approximate the height of the monument, and then see if you get the same answer as in 30. Okay, so for 31, you're going to use those measurements, right? So, but your proportion is going to be set up maybe a little bit differently, huh? So what is that 9 point? Is that 9.5? I'm not zoomed in enough to tell. Yeah, what is that 9.5? Is it a short side? Okay, it's a hypotenuse of the small triangle, Campbell. So we have a short side of the small triangle and a hypotenuse of the small triangle. Yes? So if we set that up as short over hypotenuse, and then 9.5 is the short side of your big triangle, right? And then the hypotenuse would be what we're looking for. Yes? So then what do you get there? You got 150. $15. Okay, it's 15.04, right? And then a lot of other decimals after that. So it's about 15, okay? Because it does say approximate, right? And then what about that part of the question? Okay, so think about it. Did we throw a tape measure all the way to the top of that statue's head and find an exact measurement? So how did we take our measurements? Well, we can see that the kids are 2 different heights, right? Both of their eyes line up at different spots on the statue. Basically, what we're looking at here is everything on that is kind of just an approximate measurement, because we took 7.2 squared and divided it by 5.5 and then added in 5.5. And we probably lost quite a few decimal points in there, right? And then when we did the right-hand side of the equation, again, we got 15.04 and a bunch of other decimal points too. So we weren't far off on either one of them, but it's because we were not taking exact measurements. We were using approximations. But we got pretty darn close. Okay, Lily, so you had worksheet questions. Are you still on here? Nope, Lily is gone. Number 6 on the bookwork, Isabel. Hold on, let me pull that up, okay? Okay, so for number 6, let me zoom way in. Probably what's confusing you there is 26.6 is the length of this hypotenuse of the big triangle. Okay, it's the length of that whole side. Does that help? And then the same thing for number 7. 5.8 is the length of that whole hypotenuse of the big triangle. Okay, so for number 6, if we look at that triangle, for the big triangle, we have all 3 measurements, right? So then let's look at, maybe let's look at that little triangle. Okay, you see the smaller triangle? X would be your long side, right? And then 12.8 is your hypotenuse of the small triangle. So if you set up a proportion and said long side over hypotenuse, then you could have X over 12.8 equals the long side of the big triangle, which is 23, over the hypotenuse of the big triangle, which is 26.6. Does that help, Isabel? Okay, good. I think the key to these is to look at the triangles and see, do you have the long side and the hypotenuse or the long side and the short side, and assign the labels to them like that, short side, long side, hypotenuse, so that you can see what information you have to be able to set up a proportion with. Charlotte Ann, did you have any more questions? Okay, so for 31, you're going to solve that for the same way that you would for 30, okay? Well, I guess you'll set your proportion up a little differently, because on 31 you had different parts to it. So here in just a minute, I'll post the link to the video for how to work it out on the lesson plans, and you can click that and go just scroll to the very end of the video. Will that work? Okay, so give me one of the problems for altitude. Like, is there one you're stuck on? $14 on the worksheet. Okay, hold on. Oh, okay. So on 14, first thing you have to do is look and see if it's a right triangle. So tell me, is 14 a right triangle? Okay. So since it's not a right triangle, then there's no altitude to find. That's all you had to do for that one. Did you get 15? Okay, let me pull up that. Try again. Okay, so for 15, we are trying to find the length of the altitude, right? So if we draw an altitude, it's going to meet perpendicular. Okay, you know I can't draw straight lines here. So just imagine that's a straight line, right? Now, what we know, finding the altitude can either be like it is in theorem 7.6, where we have the two segments broken out of that hypotenuse of the big triangle. But for number 15 and 16, we don't have that, right? We just have the whole hypotenuse. So what if we look at it, try to look at it maybe a little bit differently, okay? For this one, if we call this H for the altitude, right? For the height of the triangle. Then let me see if I can, I can write over there. Okay. So if we're looking for that, that's going to be the height of a triangle. If we look at that small triangle, do you see how we would have the hypotenuse and the long side of the small triangle? Okay, so if we have hypotenuse and the long side, right? So for that one, your hypotenuse would be 18 for the small triangle, and your long side would be H. And then for the big triangle, we know the hypotenuse is 30, and the long side would be 24, right? So then you've got your proportion. You just cross multiply, divide, and that will give you the altitude. Does that make sense? Okay, good. You have any more questions, or you think you're good now? Bookwork or worksheet? Okay, let me pull that page up. Okay, so number 5 on the worksheet, you're supposed to find the length of the altitude and then round to the nearest tenth. So if we look at that, it's going to be very similar to how we just did number 15, okay? We have all the sides of the big triangle, right? We have 3, 4, 5 of the big triangle. And then if we look at our little triangle, our medium triangle, we have 4. And then for the little triangle, we have 3 for the hypotenuse. We're looking for this one, right? So on the little triangle, that would be that side. And on the medium triangle, it would be this side. Do you see that? You see how I pulled that from the one picture? Okay. So now you can set up a proportion. You can either use the middle triangle, the medium triangle, or the small triangle, okay? Because you have all three measurements on the big triangle. So if you used this medium triangle, you have h for the small side and 4 for the hypotenuse. So you would set up your proportion. You could say small side of h, hypotenuse of 4, equals the small side of your big triangle, which is 3, over your hypotenuse, which is 5. Now, if you used the small triangle, okay, to set up a proportion, you have your long side and your hypotenuse. So the long side of h over your hypotenuse of 3 equals the long side of your triangle, your big triangle, which is 4, over your hypotenuse, which is 5. So see how, even though this one used the medium triangle and this one used the small triangle, we're still cross multiplying the same two numbers here and then dividing by the same 5. So we're going to come up with that same answer. So that's why I tell you guys that there's definitely more than one way to set these up. And you'll come out with the same answer either way. You're welcome. Just email me if you have more questions, okay? All right, bye.